So I'm Tess. I work at Microsoft. I'm a developer, and I've spent a lot of my time analyzing memory dumps and troubleshooting people's .NET issues. Now I mostly create my own .NET issues. And today we're going to talk about those issues, for example, crashes, memory issues, and performance problems. Essentially anything that you can't step-by-step debug. And when you can't step-by-step debug, then you're only left with a few options outside of logging. And one of those options is performance profiling. We'll take a look at that a little bit. But mostly, we're going to take a look at memory dumps. Anyone worked with memory dumps? OK, quite a few. .NET memory dumps? Yeah? OK, so we're going to talk about how you troubleshoot these issues. We're going to talk about strategies for these three types of issues, and a little bit about how you troubleshoot them with WinDBG, Visual Studio, and something called debug diag. So a memory dump, for those of you who haven't worked with memory dumps, is essentially a snapshot of a process. So there are two kinds. There's a user mode dump that is a snapshot of a process, and then there's a kernel mode dump that is a snapshot of a full system. So it's kind of a little bit like taking a picture of a crime scene, in that you can't really move forward, you can't continue debugging and see what happens next, because it's not a movie, it's just a snapshot. And you can't go back, because it's not a movie again. But you can find a whole lot of evidence of what caused the problem. So that's what we're going to look at today. So yeah, I just had to do this because I bought this new tool. And we'll start off by just looking at a memory dump in WinDBG. So a lot of people, for those of you who have used WinDBG before, WinDBG is now available as a store app. You can download it in the store, and a lot of people asked, are you going to show WinDBG from the store today? Yes, here it is. Unfortunately, you can't customize it and make things bigger, like make font sizes bigger and things. So if I would look at a memory dump, it would look approximately like this. And you couldn't see anything, so I'm going to revert to using WinDBG as it's always been. I hope you don't mind. Essentially, it's going to look exactly the same way. So what I'm going to do is I'm going to open up a memory dump, a crash memory dump of a process that, this is a WPF process, but everything I'm going to show today is going to be applicable to VPF, to any .NET process, including .NET Core. So SOS and all the tools are also available for .NET Core. This is a WPF process that just happened to crash. And I'm going to go ahead and copy in some commands here in something called a scratchpad. So a scratchpad is essentially like Notepad for WinDBG. This is just where you can type in essentially anything. Nothing will execute in here. So I can type in my Twitter handle or something else moderately useful. I'm using this just now because that way you can kind of follow along and see what I'm going to do in the dump. So the first thing that happens when you open up a dump, except for that you're probably very confused about this user interface if you've never seen it before, is that you're going to see a few things. For example, that this memory dump was taken on an unhandled exception, so a .NET exception that we didn't have a try-catch block around. This code is for .NET exceptions. It stands for CCW, for COM callable wrapper, which is a remnant of that .NET was once COM++. And we're essentially stuck in race exceptions. So we're racing some type of exception, and we can kind of figure out now from here what it is that we're doing. So we're going to start off with a simple command, ~k. You'll see that pretty much all the commands in WinDBG are kind of cryptic, leet speak a little bit. So this is leet for thread, star for every, like on all threads, run the command k, which means stack, of course. Debuggers are extremely lazy. So every command is essentially just a one. Yeah, we ran 28 commands, that's all you get. So if you run that, you'll see all the stacks. So this should be kind of familiar to you from Visual Studio and how a stack looks. We're not going to kind of delve too deep into this, but this is how you get the stacks. The difference here is that normally when you're in Visual Studio, you will see one stack. You'll see the active thread. Here you see all the threads that are in the dump. And it turns out that even in the WPF process, we have quite a few of them. 22, as a matter of fact, in a very simple WPF process. One thing you will notice, though, if I run K to look at the current thread, the one that was throwing the exception, we can see it's throwing an exception, but underneath here, there's a bunch of stuff that we can't necessarily kind of figure out what it is. And the reason for that is that WinDBG is not a .NET debugger. It's a native debugger. So it's great for C++ and things like that, but it's not so great for .NET unless you have a translator, and that translator in our case is called SOS. So we're going to do load by SOS CLR. This command, what it does is it brings in this tool SOS. It's not Save Our Souls, it's actually Son of Strike, because originally C# or .NET framework was called Lightning, and we needed something to bootstrap it, so we created something called Strike to bootstrap and also get a few commands to see what was happening in .NET. But it was kind of kludgy to use, so we wanted to make something more customer ready, and that's why we created Son of Strike. So this Son of Strike helps us. We can run a bunch of commands. I'm going to run bang, Microsoft speak for exclamation mark. So if I say that, that means exclamation mark. So bang help to see all the commands that we have in SOS. And one of them, for example, threads, will show us the .NET threads. So only like 6 of these threads were actually .NET threads. We have the one throwing the exception. Now I get a little bit more information. It's an argument.arange exception. We have a finalizer thread. In any .NET process, there's always one finalizer thread, and the finalizer thread is the one that calls all your destructors. So if you have some objects that maybe hold on to native data and needs to release them, that's happening on the .NET finalizer thread. I bring that up because if you happen to block the finalizer thread, if you happen to block in a destructor, or if you happen to crash in a destructor, you're kind of screwing up the garbage collector, and nothing will get garbage collected anymore. But one important, and probably the most important command, is called CLR stack. So this will give us the .NET stack of the thread. And now we're very much starting to look like Visual Studio, in that, for example, we have main window, next button click. This is just a click event. We called into some view model, some function there, and we threw an argument out of range exception. And at this point, it should be familiar to you as far as troubleshooting like these similar type of issues in .NET, like in Visual Studio. Now, in Visual Studio, something you can also do is look at the locals window and find out what objects you have on the thread, and that is here done with DSO, or dump stack objects. So dump stack objects will show you, here we'll have the argument out of range exception again. We actually have it a number of times because SOS is not as sophisticated as Visual Studio in terms of like collapsing where the same object turns up on multiple frames in the stack. But we can go in and click on the object and get more information about it. Click on the message, for example, and find out it was like an index out of range, blah, blah, blah. And at this point, we're kind of done with a crash scenario. We kind of gotten to the bottom of like what function it was happening in, what the exception was, and that stuff. So this is all stuff that you could do in Visual Studio. So why even bother with WinDBG in this case? Well, a couple of reasons you might want to bother with WinDBG in this case is that you might take a memory dump of a process that's not on your machine, where you can't really debug it with Visual Studio. And something else that you can do in here that you can't really do in Visual Studio is look at the objects that are in the process. So if we do e heap-gc, we'll see this is a list of all the sections of memory that we're using in .NET process. So as opposed to, for example, a C++ process or something else, so in any managed type of system like .NET Framework or Java or something that uses a garbage collector, the way it works is that the garbage collector handles any allocation and deallocation. So it creates segments and then it stacks the objects one after another. So if we look, for example, at this particular one, we'll do, and don't worry if you don't remember the command, just run bang help. I'm going to do dump heap from one address to another to dump out like all the objects on the segment. And you can see that the objects are actually stacked one after another with some free space in between. So the objects in themselves, and this is kind of true for, again, for both .NET and Java, although Java doesn't really have an SOS extension, so that makes .NET a little bit more debuggable. But what this tells us is that there's an object here, and the object has a self-contained information about how big it is and what methods and everything it contains. So if we look at this one, for example, we can see it's of this type. This method table will tell us, oh, that was not a particularly good one. The class maybe, no. You saw it before on the exception that it has like all the member variables and everything. So this is all contained in the class and the module. So it's kind of self-described what this object is, and also how big it is. So why am I bringing this up? Well, because this makes it very easy to do something like this. I'm going to do dump heap-stat, because now, given that we know where all the objects are and that they are all one after another, we can enumerate them and show every single object that is in the process. So if you can take a memory dump of a process, like even if it's not yours, like Outlook or DebianV or someone else who wrote like an app for you, if you take a memory dump of it, you'll see all the objects in that process. And you can do things like this: dump heap dash types system dot string, and we'll say I want the ones that are at least 500 large. And this will dump out all the strings of a certain size. And then I can go in and look at them, and I can find things like, like this, for example. You know? This is kind of scary, actually. But this is the power and kind of like a little bit of the downfall of having something that, so just be aware of this when you're creating your own objects, that if you want to hide something, make sure they are in encrypted strings and things, because you don't have to create, like, this does not have to be a process that you actually own, that you wrote. Now, it takes a while to dig through and find like all the stuff like that, but you can find it. So the other thing that you can do on an object like this is I can take that object and I can say gc root, and what this will do is it will look at that object and say, why is that object not garbage collected? Well, that object is not garbage collected because it is part of some configuration object, blah, 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 and eventually that configuration, like, it leads up to a root that is saved, like cached or static or something. So you can find out a lot about the objects that are on the heap. Now, you can also run something like lm, which is load modules, and this will tell you all the DLLs and all the exes that are, well, not all the exes, the one exe that is in the process. And if you click on one of them, it will give you information about like the version numbers and everything. So this is useful for if you're troubleshooting an issue at a customer's machine and you want to know, did they in fact install the latest update? Did they install this patch? What version of the framework are they running or something like that? So Let's go back here. So we looked at the threads. We can see the call stacks. We can see the objects on the threads. We can see the modules like the DLLs and EXEs and information about them. And we can also see in the .NET heap, like all the objects, we can see how big they are. When I say how big they are, I mean like how big they are, including like all the objects that they hold on to. And just dump them out. So that is when you have a memory dump. So now, how do you gather a memory dump? Well, there are lots of different ways to gather memory dumps. One way to gather memory dumps automatically is to using Windows error reporting and setting up a key to say every time a process exits, then I want a memory dump. But the more specialized ways are Task Manager, for example. This is like the simplest way to gather a memory dump. You just right-click on the process and say create memory dump. That's how easy it is. So why don't you always use the Task Manager? Well, it turns out that sometimes you might want to create a memory dump in a certain condition. Like, for example, if a process crashes, or if a process goes over a certain CPU value or something like that. And then you can use a tool like procdump. So procdump comes with sysinternals. It's a free download. And the good thing about it is that you don't actually have to install it on the machine that you're going to use it on. So that means that if you have a server that you can't install anything on, you can still use this. And grabbing a memory dump is actually a very short process. And it doesn't necessarily stop the process even for the full duration of the dump gathering. You just do it kind of in place. So with procdump, you can do things like the examples here, like if a window is hung, you do -H, or if you have an exception, like a crash, you do -E, or a -C for if the CPU is over a certain threshold or something. And then sometimes you might want to go a little bit deeper. So you might want to create a memory dump, for example, on a perfmon counter hitting a certain value. Or if you want to create a memory dump on exceptions that don't crash the process. So let's say you have a bunch of file not found exceptions. They don't crash the process, but you kind of want to figure out what they are. So you can then go in and say, hey, create memory dumps for like the first 2 times this happens. And then I'll analyze them, fix them, and then you do it again, so to speak. So debug is a more specialized way of doing things. So and then we come into how do you analyze memory dumps. We've seen one way with WinDBG. So WinDBG, you probably already have it on your machine because it's essentially installed with any Windows developer kit. But now you can also get it from the store. And then when you get it from the store, it now is ribbons. So it's a lot more usable. Yeah, I don't know why they did that. Or you can use debug. Again, debug is not only a tool for creating memory dumps, it's also a tool for analyzing memory dumps. And debug, the story behind it is that when I used to work in support, we're kind of getting tired of debugging the same memory dumps over and over and over again, because it turns out that the issues that you troubleshoot are the same issues. I mean, they might differ in that it's a different exception and it's a different thing that you're leaking or whatever, but they're very, very similar. So what we did was we created a bunch of scripts that essentially did everything we used to do every day and put them together in this tool called debug. So now you can sort of run the scripts and automatically do everything we do in WinDBG. And then only go over in WinDBG for like those specialized things where you want to know that exact object, what was that doing. But even when I debug, I use debug because it's again a very lazy way of debugging, in the sense like I don't have to go through and do everything. And instead I just let the machine work for me. So I'm going to show a few examples of how that works. And then we can also use Visual Studio, and Visual Studio has some pretty amazing features when it comes to dump debugging. We're going to look through for all 3 of these issues how that looks. So we'll start off with crashes. So if you look at a crash, what are some things that could cause a crash of a process, except for what we just saw, like an unhandled exception? Access violation? Yeah, so that would also sort of go under the unhandled exceptions. Essentially, it's basically unhandled exceptions, but there's also a couple of specialized exceptions, I should say, such as stack overflow, out of memory, and execution engine exception. And the reason these are special is because these never make it to second chance. Like, there's no way you can handle these, because if you were to handle, for example, a stack overflow exception, you would have to create another function on the stack to handle it, but you can't because you already overflowed the stack. Or if you have an out-of-memory exception, you can't create another object to do exception handling because you're already out of memory. Finally, the execution engine exception is sort of like when there's a crash inside the framework itself. So some bug or something that essentially, like something like an access violation inside the framework, then you get an execution engine exception. And most of the time, that's going to come down to a bug in the framework. Sometimes solved or sometimes not. But if you do get an execution engine exception, you might just want to check out the address of the execution engine exception, because if you search on that, you'll probably find like a KB or something, like a knowledge base article on how to solve it. And then something that we saw a lot when I worked in support was that you often get dumps that you think are crashes that aren't necessarily crashes. They're just something that killed or recycled the process. Specifically, if you're using like IIS or something, you could have something there that would kill or recycle the process once in a while. So we're going to look at how you troubleshoot one of these things. So I've reduced it down to 3 very simple steps. Check the event viewer. It gives a lot of information. And then capture a dump on the crash, and then look at the faulting stack, because there's always going to be a faulting stack when you have a crash. So we're going to use this beautiful WPF app that shows the precedents of the United States. I kind of stole this from a demo for Xbox. And what's going to happen here is that when I go and click next, yeah, we all kind of know what happens after that, but the process sort of crashes. That was what I was thinking about, at least. Okay, so so what we're going to do is we're going to go ahead and select a tool to help us figure out what happened and maybe save the world or something. Who thinks that we should use Task Manager? Okay. How about B or C? B. Proc dump. Okay, a few. And debug diag. Okay. And everyone else thinks we shouldn't even troubleshoot this issue. We should just leave it as is. Okay. So the answer is B and C. But in this case, we're not necessarily looking at a very specialized scenario, so we're actually going to go with proc dump, but we could use debug diag as well. We could not use task manager because we can't take a snapshot of a process unless we're super, super fast and know when the crash happens. So we're going to run this again, and then I'm going to start preparing proc dump. So cdu proc. Okay, proc dump, and then I'm going to run MA. So MA means a mini dump with all options, also known as a full dump. So mini dumps, if you don't do all options, what you'll get is essentially just what the threads are accessing at a time. So you won't get like the .NET heap and everything. And a mini dump, as it is typically what you will send if you have like a crash in Visual Studio or something, and it says, do you want to send this to Microsoft for them to look at? And you say, yeah, go ahead and send, I don't care. That is a mini dump that you're sending. So you should know that you're not necessarily sending a whole lot of information about your system or your process or anything. It's just like the stacks and things. And what actually happens when you do that is that it gets bucketized, and they look at, okay, so what was the stack? And it's an automatic process that looks at the stack and then sees, okay, so if we have 100 people that have like the exact same stack, then we'll start looking into that type of issue. So it gets prioritized based on how many people just happen to call in with the same stack. But we're going to do a full memory dump, so -MA, and we're going to use, I'm going to use the precedent.exe, that's the name of the process. And then I'm going to do -E, which means I'm going to wait for an exception to happen and grab a memory dump. So we'll go here and click next, and then it creates the memory dump. And this is actually the exact same dump that we've been looking at already, so I'm not going to go through that. But what I'm going to do is I'm going to go through that same thing in debug diag instead. So in debug diag, I'm going to check in crash hang analysis. So this is the default one that you're going to use for any time your process crashes or hangs. And we're going to go ahead and use the memory dump we created and just start analyzing. And now this now goes through and runs all the commands that we did. It creates a nice report for us that says it was an argument out of range exception. This was the information we saw in there. It was happening on this thread, and if we look, we'll see the exact same thing in here. Next button click, it was going to this method and whatnot. And we can actually, like, so at this point, like, you wouldn't even have needed to go into WinDBG, right? And we can also look at, like, if there was some other exceptions that happened recently, and we'll actually see these. So out of memory exception, Stack Overflow, and an execution engine exception, those seemed kind of familiar, right, from the presentation. It turns out that because of the nature of those, they can't be created when they happen. Like, you can't, again, create a Stack Overflow exception when a Stack Overflow happens. So they're pre-created. It doesn't mean that they actually happened. They're just on the heap for, like, if they're needed. But this is how easy it is to do the same thing in debug diag. But we're going to go actually one step further, and we're going to open up the same memory dump in Visual Studio. So I go File, Open File, and click on that. And what we see in Visual Studio now is a list of all the modules. So these are all the DLLs that were in the process. And again, we have the information about that we got from LM in WinDBG. We can also see it was a .NET exception. I'm sorry if you can't really see in the back, but it's the same status code we saw before. And then I'm going to go in and say debug with managed only, which is now going to go and debug the dump for us, like open it up. And this will take us to the exact line where the problem occurred. This is pretty cool, I think. Now, this can be done if you have the source code on your system and you have debug symbols and a few other things. But this is extremely useful because now we're suddenly in a tool that we know with an exception. Like, it looks essentially just like if we were debugging this normally in Visual Studio. And we can even look at like values or locals. It will show, like, instead of doing DSO, we can just look at the locals and everything. So very useful. If you didn't have this source code and everything, you would still get the call stack, you will still get the locals and everything, you just wouldn't get the code window. Okay, so let's go ahead and close that out, and this, and move on to here. No. Okay, so, check the event viewer. That was, of course, my first step, and I didn't do it. So we're going to Windows logs, application. Okay, so here we have the application error. And if we look at that, we would have actually found out that the process was terminated due to an unhandled exception. This was the type. Here we have the call stack, the exact same call stack we've already seen a number of times now. But then we wouldn't have gotten to debug. So yeah, don't look at the event viewer. Continue looking at dumps. Okay, so that was troubleshooting crashes. Now we're going to go on to performance issues. Performance issues obviously come in a lot of different forms, like the app is not responding or requests take too long. Like if you have an issue where you find, for example, your web requests and you think that they take too long, be kind of clear about how long they should take, because otherwise you might end up troubleshooting until you're blue in the face. And then we have issues, for example, where the CPU goes haywire, so you have high CPU issues. What's the cause of a performance issue? Well, there are two types of performance issues. There's high CPU and low CPU hangs or performance issues. And typically, a low CPU means that you're waiting for something. You're waiting for a database. You're waiting for a web service. You're waiting for some kind of other process to do something. Or you're in a deadlock, which is a lot less common, but obviously happens. And then for high CPU, either you're in a busy loop, but more often than not, you're going to be in a high CPU in GC scenario, where you're kind of overstressing the GC. And pretty much the only way to overstress the GC is to create a lot of very large objects. One that's happened ever since .NET was in the alpha stage was that people keep concatenating strings. And strings are immutable, which means that they can't kind of grow and expand. The reason, of course, being that once you've seen how the objects are stacked right behind each other, and if something were to expand, you would have to move everything underneath it, which isn't very useful. So that means that to create a larger string, you would have to create a new string. So you would create, like if you concatenate very large strings, you create tons and tons of new strings. And that will mean that you have to garbage collect a lot. So if you have a performance issue, what you do is you look at if it's a high or low CPU issue, mostly because that will tell you kind of what to look for, if you're looking for a wait or if you're looking for a busy process. And then you capture one or more dumps. So you might want to create a few dumps to kind of see if the process is at all progressing or if we're essentially stuck in the exact same place. And in this case, we don't have one single culprit. We don't have the one thread that crashed the process. All the threads are interesting because we don't necessarily know which one contains the request that is hanging or which one is blocking the process. So we're going to look at all of the stacks. And if you can't repro in test, or if it's a very small hang, or if it's a very small performance problem, then you might want to do profiling instead. So we're going to look at how that looks. So we have a process right here that has some fairly slow requests. So when I click on products, it takes a while. What I'm going to do is I'm going to go ahead and stress this. And for this, I don't recommend this as a tool. Well, I don't disrecommend it either, but it's something called Netling that I've downloaded from GitHub. What it does is basically it sends tons and tons of requests. You decide how many, but it just sends like single requests. And so it's not a load test tool. It's just a tool that will at least send a ton of requests. So what we're going to do is we're going to send requests to this products page. I'm going to send 8 of them at the same time. And I'm going to go ahead and keep sending requests for 10 seconds. And I'm going to look at the task manager to see if this turns into a high or a low CPU thing. So first off, let's see here. In task manager, I'm going to find my process, which, since it's IIS, is going to be W3WP. ST here. Okay, and I'm going to focus on this number here. This is the CPU usage. And I'm going to kind of narrate because you can't see it in the back, but it's 0, it's 0, it's 0, it's still 0, 1. So it's, it's not using a whole lot of CPU. So apparently a low CPU type of hang. And I'm going to run this one more time. And this time I'm going to create a memory dump while the process is kind of slowly progressing. And you saw how fast that was, and that actually created a pretty sizable memory dump. So now I'm going to go ahead and open this up. Let's see, in WinDBG. And I'm going to load up, load by SOS CLR, just like we did before. And this time I'm going to run CLR stack on all threads. So ~* for all threads again. And when you run something in an extension, so SOS is an extension, you have to do E for evaluate. And I'm going to run that. So this is now going to show us all the threads. And we can scroll through and just look at one of them, for example, and see that we're in the products controller. So this is the products page. We went into data service and got all products, and then we're stuck in some kind of wait. So we would obviously, the next step would be to go in and look at this method and see why we would be waiting and essentially why that could take so long. And then our work would be kind of to squint and look really fast and see if all of them look the same. And this is a skill that you pick up a lot when you're doing debugging of large dumps. Or you would just write down kind of like the stacks and kind of compare them. But because debuggers are kind of lazy again, this is all done for us in debug diag if we go in and use the crash hang analysis. So what this will do is, again, it will go through and look at the most common reasons for crashes and hangs, and create that nice report for us that tells us that all of these threads, because now, since it's automated, it can do the comparison itself, all of these threads are sitting in a wait. So now we know that we do have an issue because a lot of threads are sitting in a wait. It gives some other useful information, like debug is set to true. That shouldn't be done in W3 WP process. So go in and look at this article on why that's bad, that kind of stuff. And throughout, like whenever you do a reporting with debug diag, you'll see a lot of hints and things that point to articles that kind of tell you more about how to debug those specific issues with WinDBG. But we can take a look at that thread and we'll see, so here it is listed all the threads that have the same stacks together, and we immediately know, we don't have to squint, we can see that all of them kind of have the same stack. And again, this is the same thing here. So at that point, obviously, we would go in and kind of analyze what that method was doing. But wait, there's more. So we're going to go into Visual Studio and perform some magic. So file, open, file, and look at that hang. And I'm going to debug with managed or debug with mixed is kind of like the same thing, except for with debug with mixed, you also get like the C++ part of the stack, or like the native part of the stack that's got the framework and everything. Most of the time, if you're looking at your own code, that's not very useful. So then this happens. Why does this happen? Anyone? No symbols and no code. Actually, I do have symbols and I do have code, but symbols are actually not necessarily needed here. The reason why this happens is because we didn't capture a memory dump at a specific action. We didn't capture a memory dump like on a crash, for example. So we don't have an active thread that has .NET or has a CLR stack on it or something like that. Instead, thread 0 is probably busy doing something else that I don't have code for. But remember, in hangs, we're looking at all the stacks, not necessarily an active stack. So what we're going to do is we're going to go in and look at debug windows and a tool called parallel stacks. So this is something that you can use even when you're debugging normally, like if you're step-by-step debugging, you can use this parallel stacks thing. And what this will do is it will show you the stacks of all the threads that are in the process. All the .NET threads in this case, because we're using managed only. And it will tell us that we have 8 threads that are all in this exact same stack. So they're all in this products controller index in get all products. And in fact, here are all the threads that we have in there. And if I click on that, and I click on one of them, it will take me to the exact point in the code where this happened. So again, if I have the code lined up and everything, like this is some really powerful stuff for troubleshooting these kind of issues. And obviously I faked a delay in here. This would normally be like a call to a web service or something. But yeah, I think this is pretty nice. So let's see. So that was how to troubleshoot a hang. So find out if it's low or high CPU, in this case low, so we're going to have waits or something. If it was high CPU, we'd look at what the threads were doing, because it would actually be in some kind of busy state. And then we captured one dump in this case. We could have captured a few, and look at all the stacks with parallel stacks in Visual Studio or with the tilde star Bang CLR stack in WinDBG. But sometimes we have issues that are a little bit less pronounced. So, for example, if I'm going to exit out of this, and I'm going to open the same project like the precedence app again, because it has another little performance issue. Like if you look at the picture of the precedent, when I click next, you'll see that sometimes it kind of stutters. Like we can't see what's going on, but sometimes it takes a while for it to actually update. And if we want to troubleshoot that, we would go into Visual Studio. And this obviously requires you to be able to troubleshoot it on or reproduce it on your machine. But then we would go in and say, analyze and use a performance profiler. In this case, you can profile either a process that you're just going to start, or you can profile a process that's already running, or even a web process. We're going to start this particular process. And then it asks us what type of profiling we want to do. And for performance profiling, if it's like slowing down, you have 2 options. You have CPU profiling, or you have instrumentation. So CPU profiling is meant for high CPU issues. And what it does is it goes in and kind of says, what's on the stack, what's on the stack, what's on the stack, what's on the stack, and it does that like every so often. And then it summarizes and figures out who spent the most time on the stack. Whereas instrumentation, what it does is it puts a marker in the beginning of a function and at the end of the function, so you can look at elapsed time. So this is for low CPU issues where you just want to see who spent, like in what methods did we spend the longest time, so the longest clock time. And this, I happen to know that this is a low CPU issue because I created it. And then, so I'm going to use instrumentation. And I'm going to launch the process. Okay, and then I'm going to reproduce the problem a little bit, like that, and then I'm going to stop profiling. So what this will do then is it will tell us basically exactly where we're spending our time. We're spending, in this case, most of our time in the application run method, maybe not very surprisingly, because that's all we're doing in a process. And then out of that, we're spending 37% in next button click, and that is just how much I actually managed to go in and click. And then you dig through and say, okay, so it spent pretty much all of that time in this go to another method, and in this setter for precedent to display, in erase property change, and then in a converter. So a converter, for those of you who don't know, in a SAML application, you can have converters that convert like whatever you data bind to other values. In this case, what we're actually converting is the party that the precedent belongs to a color. And in that get color method, we're spending most of the time in a weight, like in this particular weight. So this is essentially like how you just by clicking, dig into exactly where you're spending most of your time and kind of minimize that. And this doesn't even have to be something that's a real performance problem, but this is a way for you to kind of look through your application and see sort of where you might be able to optimize your code a little bit. Okay, so we're into the last stretch, which is memory leaks. And memory leaks, you see them as out-of-memory exceptions or as slow response times because the CPU is too high in garbage collection or something. Or maybe you look at perfmon or task manager and see that the memory is very high. So the question is, in a system where you have a garbage collector, how can you even have a memory leak? It should pretty much not be possible. And really, the only memory leaks you will have are where you properly leak memory, or if you call into native code and that allocates something and you don't free it. But there are ways to kind of fake leak memory in .NET in the sense that you're holding on to memory that you shouldn't actually be holding on to. And one of those, for example, if you put a lot of stuff that you shouldn't be putting in cache, or you're keeping too much in cache or session state, or statics, or if you're blocking the finalizer so you can't finalize anything. And that happens quite a bit when that you're sort of like linking to things that you weren't expecting to link from. And then you have assembly leaks. Those are not super common, but there are certain constructs like regular expressions that will create dynamic assemblies. And if you create a lot of regular expression with the wrong kind of constructor, you'll leak assemblies. Again, not very common. And then, of course, there's native leaks when you call in to come objects and they leak. So again, our simple three-step process. Capture multiple dumps, and this time it's a really good thing to capture a lot of dumps, or at least two, because then you can compare sort of what was the state first and what kind of objects did increase. So when we look at dump heap, what kind of objects do we have more of? Because if you're not very used to looking at memory dumps, you'll probably go down like a rabbit hole of looking at strings and figuring out why they are around, not realizing that there's always like tons and tons of strings and you shouldn't worry about them too much. And then once you figure out what is leaking, then figure out why they're still around. And then for native leaks, where you do actually leak and don't free stuff, there is a thing in debug diag that allows you to do leak tracking, which is essentially just finding out when you allocate something and when you delete something. So we're not really there yet. Okay, so let's go ahead and look at how that would look. So we have a memory dump of a leaking process. And if you remember from before, first off, load by SOS CLR. One useful thing was to look at dump heap stat. I don't know why this exception keeps happening, but let's not worry about that too much. Now, this blue thing that was here, like the thing that that you can click on, that's called debugger markup language. Turns out that has a real performance issue when you troubleshoot, like when you try to dump out a lot of them. So I'm going to do prefer DML 0. This is not something that you would normally have to do, but I'm just saying this for let you know why I'm doing that. So what we have here is all our objects listed in order of size, like so the objects that take up the most of the memory. This will always, always, always be strings, integers, and character arrays and object arrays, essentially arrays of some sort plus strings. It doesn't mean that those are necessarily leaking. It just means that when you look at objects, for example, if you look at I don't know, you look at my page, for example, the only thing that is going to be listed as the size of that page is links to whatever it holds on to. Whereas for arrays and for strings, we're going to list the total contents of the string. So that's why strings and object arrays always show up at the bottom. So we can kind of go past the arrays and take a look at the first object that's sort of like not an array or not a string, which in this case happens to be an HTTP context. And we can see that we have 31,000 HTTP contexts. So an HTTP context is something that is created every time you create a request. And it's part of like the web request process, so in ASP.NET. So having 31,000 of them means that for some reason we either are calling 31,000 pages right now, or we're leaking them somehow. And we can also see that we have the same amount of HTTP requests, not uncommon because they kind of like link to each other. And we have a bunch of other ones that are also kind of part of the same thing here with 31,000. So this HTTP cookie collection, we have twice as many of that. But if we take a look at, let's say we take a look at this HTTP request. So we're going to grab this. This is a method table. This is the descriptor. So we're going to do dump heap -mt for that, and dump them all out so we can kind of figure out why they are still sticking around. Yeah, 31,000 is quite a bit. Now, if SOS could only be written by someone who is smart enough to let it cancel in the middle of the operation. No. Well, while we're doing that, I'm going to go ahead and just open up Visual Studio because we're going to use it in a little bit. Okay, taking a little bit longer than I thought, so we're going to go ahead and open up that same memory dump in here. And what this is going to do, it's going to go through and do essentially the same thing. We're going to actually pick, in this case, debug managed memory. So what this will do is it will go through the heap. It will basically do dump heap -stat. Dump out all the objects, and it will also look through and dump out, like, and figure out where everything is rooted. So it's a pretty useful thing. We're going to let that run and see where we are with the memory dump. Did my debugger just leave? No. Okay, so here we are. So now we can take one of those objects that we dumped out, and we can just do gc root to figure out sort of why it's sticking around. And again, the bigger the process is, the longer this will take, but we can see that this particular HTTP context is eventually part of a news controller. So controller, obviously, if you know ASP.NET MVC is just the page, the news page in this case. So we have a bunch of those hanging around, and those seem to be hanging around in something called a cache item removed callback. Don't worry if you don't know what this means, but this whole thing is how it's sticking around. And this is essentially what you would do to figure out why these are around. Now I'm going to go in and show you in here what that actually means. So I'll open up. Damn it, I thought, okay. Okay, so if we go through and look at the pages, controllers, the news controller, right here. So what I did was I went through and created a cached an object for every time we created a request. I cached an object, and I said when this object expires from cache, which happens in 5 minutes, then go ahead and call this function removed callback. This might be to clean something up when the cached object expires or something. And the problem here is that this removed callback was called as an instance method instead of a static method, which means that all the way, like all the 5 minutes that we're caching this particular object, we also have to cache this news controller in order to be able to call this removed callback function. Don't worry about that particular detail because it's not super important. This is just a means of showing you how to figure out how to get the GC root and everything. Now, as the very last thing, I just want to show you how to do this in Visual Studio. And what I've done then is I've gone through and opened up the memory dump in here. And, why did that not happen? Okay. And then I also created a baseline. So at process start, I created a memory dump. And this is what I was talking about with creating multiple dumps. And now it's listing all the objects for us that are in the heap. And we can look at the inclusive size, which is the size of the object plus all the objects it holds on to, and sort that. And now we can see, for example, that news controller in here is one of the biggest culprits for memory usage. So this is a very much easier way to figure out what you're leaking. And then right down here, it has whatever was shown with GC root telling us exactly why it was sticking around because it was sticking around because of this cache item removed callback. And that, my friends, is how you troubleshoot a memory leak. Capture multiple dumps, look at what's leaking, find out why they're still around, and use leak track if it's a native leak. And with that, I hope you're ready to go on and take on the world and troubleshoot all those issues and look at those crime scenes. So thank you.
Wow. Mind blown. Any questions?
I have a question. Is it possible somehow to get notification using the UI thread too much? Or I want to get, I don't want to reproduce mistakes because it's hard. So I want a notification. Right now you're using the UI thread too much, or right now.
So so you want notification on when you're using the UI thread too much, when you're debugging the process, or when like in general?
Yeah, for example, in Android you get this. You're using the UI thread too much.
Okay.
You skipped these frames.
Yeah.
What?
So.
Yeah.
Go ahead. Someone back there said. Oh, use the mic. Okay, so you said in Android you get a notification when you use the UI thread too much. Are you talking about when you're debugging or when in general?
Yeah,
when you're
Yeah,
passing.
I just want to get notification when,
Okay.
for example, UI thread is used too much.
Yeah. So for example, when you with the profiling bit,
Yeah.
in there you can definitely get those kind of notifications. And there's like a whole set of debugging tools in Visual Studio that will show you usage, and especially when you profile, that's useful. You can zoom into that particular point and figure out what you were doing during the time that the UI thread was blocked or overused. And yeah, there's a lot of markers and stuff like that. So in Visual Studio, you just use the there's a whole debug window that you can use and look for that kind of stuff.
Is it also possible to do a query of a dump? Like if you take a dump and I want to know some UI thread again, when was it used too much?
Okay, so is it possible to query off the dump when the UI thread was used or not? Not really, unless you added some kind of profiling in the memory dump that recorded that, but it's not recorded necessarily by default.
Okay.
So in the memory dump, you can only see whatever the memory is right now, and the only way you could see something like that would be if if the framework somehow recorded that and had an object that contained that kind of log information, which it does not.
Okay.
Yes.
Is there a tool
I can repeat your question. So you know.
for people outside of Microsoft? Would you recommend a tool for gathering dumps from the wild?
For people outside of Microsoft, I recommend a tool for gathering dumps from the wild. So, are you talking about outside of the company Microsoft, or outside of the
Just people who don't have Watson.
Oh, people who don't have Watson. So, I mean, WER, which is Windows Error Reporting, that creates Watson dumps. Is that what you for gathering dumps, or you can use procdump?
No, I just meant a company, like delivers a product, it lives out in the dump, and then they're getting crashes.
Yeah.
How will they collect the dumps?
Okay, so you can do that like inside the process itself. You can generate dumps. There's, for example, a thing called CLRMD, a NuGet package that you can download, and you can use that both for creating memory dumps when your process crashes, or when you get a certain. It doesn't even have to crash. You can just create a memory dump at whatever condition you want. And you can also use CLRMD to automate like a similar process to what Watson does, in like looking at stacks and kind of categorize them and thing. So CLRMD is your friend.
Thanks.
Crystal clear for everyone else. So, thank you.